Hello, and welcome back to my multi-part video on patching up large polyphonic generative Krell patches, or as I like to call them, Polykrell patches. So we've done a lot of previous videos that were really all about getting us to this point. It was really all about creating enough material to then be able to work with that material and create a finished piece. So now we've gotten to the point where we can start to take all these different voices that we've got. And you may recall that we've got a melody voice, that's what we're listening to now. That's the red trace on the scope. We've got a bass voice, we have a counterpart to the melody voice, and then we have two 3-voice paraphonic voices coming from 2 telharmonic modules in shift register mode for a total of 9 voices of polyphony. So now what I'm going to do is I'm going to show you a little bit about what I've been talking of when I've talked about leaving spots open, leaving little portals open in the patch that we can then go inject some voltages and start to get some changes. So the first thing that we're going to look at is we're going back to our old friend the Quadrax. Now the Quadrax is really doing much of the heavy lifting here. It's running 4 separate Krell envelopes, and so it's driving the bass on top, the 2 paraphonic harmony parts from the telharmonic, and the bottom is our melody. And then off screen I've got maths running the counterpart voice on channel 1. So we've got 5 Krell functions running simultaneously. When I originally set up Quadrax, I very purposefully left CVA input empty. And so since you've seen it in the last videos, I've now got this pink cable coming in. And so what I've done, and we can just go over to our melody voice, put it in CV mode, we can see that the original 2 CVs, CV, C, and D, are still assigned to send signals to our rise and our fall. That's what creates our continuously changing Krell voltage. But you can see that I've also got CVA doing something. So if I click on CVA, you can see that I've got red lights on the rise and the fall. So what I'm doing is I'm using a cool aspect of Quadrax that lets you take these incoming CVs and sum them together and assign them to a single spot, to a single destination. What's great about that is you can take all 4 CVs that are coming into your Quadrax and you can have them all go to one spot, like the fall or the shape or the level. And in fact, you could have all of your 4 CVs all going to all 16 destinations in Quadrax. So what I'm doing is I'm using an incoming steady voltage on this pink cable into CVA, and I'm assigning it to my rise and to my fall. And you'll notice that we've got red lights, bright red lights, which tells us that I'm assigning it completely 100%, but I've inverted it. That's why those lights are red. And the reason that I've inverted it is that, like maths, if you add a voltage or you modulate in the positive direction, either the rise or the fall, it gets longer. But what I want is I want the opposite. I want a positive voltage coming into CVA to take my rise and my fall and make them shorter. So what I do then is I set up my rise and fall to be relatively long on channel 1, and then I'm using this incoming inverted voltage to shorten it. So I'm just going to pop back into channel mode, and then we can see that's the melody there. You can also see it on the scope as the red trace. Now if I go to our voltage and I start to increase that voltage, we'll see it change on the Doepfer VU meter that's tracking that steady voltage. And as the voltage changes, we'll hear that Krell function generator start to speed up, just like I was doing in the last video. We can see our VU rising a little bit. We can hear our Krell function generator speeding up. Now I'm just going to slow it back down. So one of the other things that I did with that same voltage, because I've got it going several places at once, is I'm also using that same voltage to change the modulating LFO's rate for all of the Krell envelopes. So you may recall from the diagrams, I've got 3 LFOs all coming from LiveWire LFO modules, and they're the modulations for the Krell. And so they've just been sitting in the background this whole time, running away, doing their thing at a steady rate. But as the rise and the fall of our Krell envelope speeds up, we want those modulating LFOs to also speed up so that we're preserving these Krellish shapes that we like so much. So I'm just going to move our camera over. We're going to take a look at those. So you can see our Dalek modulator and our Vulcan modulator that we're using to modulate the Krell. And I've got inputs plugged in because these are voltage controllable LFOs. Now they don't necessarily allow you to control them in 1 volt per octave sort of way, so they're a little bit non-linear in terms of their response, but they will speed up as the incoming voltage speeds up. So I'll start to speed them up. We'll hear the Krell speeding up, and we should see 3 lights flashing. So that's these 2 and this one on the left. And then if I slow back down, they'll slow back down as well. And you can see on the scope that the shape of the curves will change a little bit as those modulators speed up. But that's not all that we've got going on. You may recall from the earlier videos that all along what I've planned to do is to drive the whole patch from a single U-scale quantizer. And we're just going to move the camera over. We'll take a look at that quantizer now. And there's our quantizer. You can see that our quantizer is set to an E-flat minor pentatonic scale with a second thrown in there for good measure. But I've also got the U-scale in one of my favorite modes that it will do, and that's CV controllable scale mode. So I've gone ahead and I've put together 3 different scales that we'll use for this demonstration, and I've put it into the position where an incoming CV will call up those scales, and the U scale lets you call up 8 different user scales, one of its most powerful features, I think. So if I slow down my Krell function generator, which is slowing down my Dalek modulator and my 2 Vulcan modulators. So now my melody is slowing down, and you can see the voltage dropping on the dope for VU. Eventually, when I get low enough, lo and behold, that quantizer changes scale. And because the melody that we're listening to is 1 single note, the next note that it grabs is now from this scale. So now this is a C sus2 chord with a major 7. And then we can hear the melody much more slowly making its way through that scale. Please consider joining my Patreon. It helps me to make more videos and make more music. I always enjoy hearing and seeing your examples, so please don't be afraid to reach out, either on ModWiggler or here on YouTube. Thanks so much, and we'll see you next time.